Hello guys, welcome back to my channel. Today my topic is the basic concept of set. So definition of set is: a set is a collection of well-defined and distinct objects. It is a collection of well-defined and distinct objects. So what is meant by well-defined? Well-defined means we all know that it's a clearly defined or described, right? Which is known. Which we know clearly about something that is known to us. And distinct object, which means, suppose we have two objects here, x and y. So suppose if x has one element, then y has two elements. The difference between this and this should not be same, right? So if this is good, then bad, distinguish. So this is called distinct object. So example is set of all the months in a year. We all know that we have 12 months, right? 12 months in a year. So it's a set which is well known, right? 2 is set of all the vowels in alphabets. So we all know that we have 5 vowels, right? Which is known to us, so it's also a set. Set of all the Dallas boys in school. So how do you think? Is this set or not? Set of all the Dallas boys in school. So see, Dallas boys in school, which means Dallas boys, which means it might be 12 Dallas boy, $15 boy, or $50 boy, which is unknown, right? So this is not a set, which is unknown, so this is not a set. Okay, let's discuss the methods. So we have here, there are two methods. Roster method: when the elements of a set is written inside braces, that is, this is the braces, right? So if the elements is inside these braces, it's a roster method. See, example 1 is inside the braces 2, 4, 6, 8, right? So this is a roster method. Here also January, February, March, right? So which is close by braces, so this method is called roster method. And P is set builder method or rule method. Many a times the number of elements of a set is infinite. We all know that infinite is uncountable, right? Which we cannot count. And set builder method help us to write the elements. So see, set A equal to x, where x is a natural number. We all know that natural number is an infinite, right? The set of natural number is an infinite set. So like these kinds of elements which is infinite, this builder method help us to write the elements. So I hope you'll get this. Okay, let's talk about kinds of set. So kinds of set, right? So number A is singleton sets. Sets having one and only one element, which means set A equal to, we have here only one element, so it's a set. Singleton sets. B, bare set. A set having two elements, only two elements, bare, which we all know that bare means two, right? So a set having two elements only. Set A equal to 1, 2, which is two elements. C is finite set. So what is mean finite? Which is countable, right? A set having countable number of elements is called a finite set. Here, set A equal to AP deal YZ, which is finite, right? Here B equal to 1, 2, 3 till 10. It's also a finite. So now let's come to T. D is infinite set. A set having infinite number of elements. This and this, this is finite and this is infinite. So this is a countable number and this is uncountable, which means we all know that infinite means uncountable, right? So A equal to 1, 2 till n. N means we don't know the value, we don't know the elements, so it's an infinite set. So E, null set. A set having no element, it is denoted by null. So see, example is all married bachelor, right? So okay, let me show you an example. Suppose set A x set A equal to x, where 9 is smaller than x is smaller than 10, right? So x is a natural number. This is a natural number. We assume this as natural number. Here, suppose x is a natural number. This one will be a null set, because there is no natural number between 9 and 10. So between 9 and 10 there is no natural number, but here in questions we have between 9 and 10 we have x. So and it is saying that x is a natural number, right? But see, between 9 and 10 there is no natural number here. We have only point, right? 9.1 or 9.2, right? So this is not natural number, which means it's a null. It's a null set. Okay, let's come to F. Equal sets. Equal means the difference between two is equal. If A is equal to 1, then B is also equal to 1. So which means A is equal to P. So two sets A and P are said to be equal if they have exactly the same elements, and we write A is equal to P. So see, set A is, it has 4 elements, 1, 2, 3, 4, and set P 2, 4, 3, 1. But all elements of set A is present in elements of set P. All elements of set A present in P. Therefore, it's a equal set. G is a set A is said to be a subset of a set P if every element of A is also an element of P. So if A, this is an element, this is a set, right? So A belongs to set A, which implies A belongs to set B. So this element is present in A and this is also present in B, which means A is a subset of B. That is, A is subset of B. If A is an element of A, implies A is also an element of B. So see here, set A equal to 1, 3, 5, right? So set B equal to 1, 2, 3, 4, 5, right? So see, the elements of A is 1, right? So 1 is also here. So it's a subset of B. See, 3 is here and 3 is also here. So A is subset of B. 5, 5, right? So subset of B, which means A is a subset of B. I hope you will get it. So H, proper subset. If A subset P and A is not equal to P, then A is called the proper subset of B and B is called the superset of A. So see, set A equal to 1, 2, 3, right, is a proper set of P 1, 2, 3, 4, right? So if A is subset of B, A is a subset of B, right? Subset means the elements of A is equal to elements of B, right? I mean the elements present in A should be present in B, so it's a subset. And A is not equal to B. Here we have 4, but here we don't have 4. Set A don't have 4, but set B have 4, which is not equal. So this is a proper subset of B, and which means B is called the superset of A. B is called the superset of A. Now we have here Bauer set, right? The collections of all subset of a set A is called the Bauer set of A. It is denoted by C, Bauer set of A. If A equal to set itself AP elements, right? Then B Bauer set of A. Bauer set of A equal to C presses elements A, elements B, AP set itself, right? Set itself elements AP, and this is null. I'm so sorry that I didn't tell you about this. This is a null. This is a null set. We did not null set as this, or we call it as /0 /0 /0. So null denoted by this, it means null set denoted by this symbol. So we have Bauer set A equal to element A, element P, and set itself AP and null. So what is a Bauer set? Which means it is a collections of all the set, right? It's a collections of all the set. If A has n elements, suppose if A has n elements, right? Suppose if A equal to 1, 2, n times, so which is n elements, right? So in that case, we will write n close bracket, right? Power set of A equal to 2 to the power n. Okay, suppose we have A equal to 2, then n equal to 2. We have here A equal to, right? So 2 equal to 4. So this is the answer, which means if A has n elements, then we will write n power set of A equal to 2n, number of elements of a subset. Okay, now universal set. So what is universal set? Universal set is the set of all the sets. The universal set is generally denoted by U. Okay, just take it as U. See, universal set means all the elements of A and P should present here. See, universal set equal to U equal to union equal to 1, 2, 3, 4, 5 till 100, right? Yeah, it's a natural number. So set A equal to 3, 4, 5, 6, right? 3, 4, 5, and here we have 6. So A is subset of universal set, right? And here P 10, 20, 30 till 100, right? So here if we write here continuously, then we will see 10, 20, 30 goes on till 100. So the elements of P is present in U universal set, so P is a subset of U. Okay, that's all for today. I hope everyone will get it. And if anyone has any problem or any query about this set, please let me know in the comment section. Thank you so much for watching my video. Please support me with your likes and subscription. Thank you so much once again, and God bless you all.